our topic for today is temperature and its measurement. That is the temperature of the body and how to measure it, especially the instrument or device that we use to measure the temperature of the body. Now, before we go on directly, we need to relate the topic to one particular topic that has direct relationship to what? Temperature, and topic is what? Heat. That's why they normally combine it and say heat and temperature. And what is their relationship? You see that in the certain formula that you still come across in the future, we have heat energy is equal to mc theta. So from this formula, it means that the heat content of the body depends directly on the mass of the body, specific heat capacity of the body, and temperature change in the body. Therefore, the quantity of heat in the body depends directly on the temperature. Now, let's start from the definition. We say heat is a form of energy that transfers from hot body to cold body, while temperature is degree of coldness or hotness of the body. That is not only the difference between heat and temperature. Now, we measure heat in joule. That is, the unit of heat is what? Is joule, while the unit of temperature is either Kelvin, Celsius, or Fahrenheit. Now, another one is we can measure temperature directly with the aid of a device or instrument called thermometer, but we calculate it with the aid of some formula like this. Obviously, I have another one under electricity. Now, another one is heat is fundamental. Temperature is fundamental. Don't forget, in our first topic, our first video, we have fundamental quantity and derived quantity. One of our fundamental quantity is what? Temperature. Why heat is derived quantity. Consider, even from this formula, it shows that it is what? Derived. The combination of mass, specific heat capacity, and temperature. Now, let's go on into today's business, which is what? Temperature. Like I said, is the degree of hotness or coldness of a body. Now, to measure the temperature of a body, we need a device called thermometer. Now we have different types of thermometer. So you cannot just say, that's why the importance of thermometer is that it settles the problem or the argument. You may touch your friend's body because you are having below normal temperature. The normal temperature, let's say the normal temperature is 37 degrees centigrade. If your temperature is 35, abnormal, you are the one having problem. If you now touch this person's body, because we said it move from higher temperature to lower temperature, this your body, in your own body you feel hot. You now think as if it's your friend that's having problem, because it will move from your friend's body to your own body. That's why, my friend, your temperature is high, or you are having high temperature. So without the instrument, the function in the instrument will now come and settle the case. By the time you use thermometer will now tell you that, oh, you are not having what problem? You are having below normal temperature. So we have different types of thermometer. You cannot just say, because you want to measure the temperature of a body, you use any thermometer. The thermometer we use depends on what we want to use it for. We classify thermometer based on what we want to use it for, and in some cases we classify it based on what is inside the thermometer. For instance, we have some of them here. We have liquid in glass thermometer. We call it liquid in glass thermometer because what we have inside that thermometer is liquid, and the major two liquids that we normally use is what? Alcohol or mercury. So in short thermometer, we have mercury there, or you have alcohol. Then we have gas thermometer, where you have what? Gas inside. We have resistant thermometer. What is inside is what? Resistant wire. Then we have what? Thermocouple. From this one, couple means two. So it means inside you have two dissimilar wires. Then we have bimetallic thermometer. What is inside is also what? Two from this bi. Two dissimilar metal. What is inside the thermometer is called thermometric substance. What will indicate the increase or decrease in temperature is what we call what? Thermometric substance. Now, if you look at it, you see that we did not mention water. We don't use water as thermometric substance because what? because of some reason. One of it is that water does not expand regularly. Water does not expand regularly. That's why we have what abnormal expansion of water that we call anomalous expansion of water. Now, we normally use mercury and alcohol. Look at this thermometer now. What is inside this? This is one type of thermometer. This one can measure up to you look at it very well. I don't know if you can see it. The highest temperature that this one can measure is 100. So it means what is inside is what? We call this one Celsius scale thermometer, because the highest temperature that can measure is 100. Now we have some that can measure more than that, especially when you have mercury inside. That's why we need to differentiate between the mercury and alcohol as thermometric substance. We have some differences here. Mercury as thermometric substance, alcohol as thermometric substance. In case of mercury, mercury has high boiling and melting point. So mercury can measure up to 357 degrees centigrade. That is highest temperature that mercury can measure, while its lowest one is 35. So it can measure minus 35 degrees centigrade. But what of alcohol? So the highest temperature that alcohol can measure is 78 degrees, while the lowest one is minus 115 degrees centigrade. You can see that depends, like if somebody wants to measure temperature like minus 100 degrees centigrade, it means we cannot use what? Mercury in glass thermometer, because the lowest one that mercury in glass thermometer can measure is minus 35. But this one can measure up to minus 115 degrees centigrade. So which means the temperature you want to measure the thermometer you are going to use depend on the temperature of the body that you want to measure. We still have other, don't forget, we have a clinical thermometer. We call it clinical because of the environment we use it and what we want to use it for. We use it in clinic to measure the temperature of the body. In that case, that one can measure between 35 and 43. Now, another difference between mercury and alcohol is that the alcohol has what? Good thermal conductivity. That's why it expands what? Regularly. So another one, it expands regularly because it has what? Good thermal conductivity. But alcohol has what? Poor thermal conductivity. Then it expands what? Irregularly. Then mercury does not wet glass. Look at this one now. This one is alcohol. That's why it's colored. So mercury, if you use mercury alone, you see it directly because the glass is what? Colorless. If you use alcohol, alcohol is also colorless. So before you can use alcohol as thermometric substance, you need to color it. Like this one, you can see that it is colored, so that you can see it at its what? Rising or falling. So that's why the mercury in glass thermometer is preferred in most cases than that of alcohol. Another one is what? It is opaque. That is, we can easily see it. We can easily see the what? Mercury because of its color. But if it is alcohol without colored it, you will not see it. So those are the some of differences between alcohol as thermometric substance and mercury as some thermometric substance. Then the next one is fixed point of thermometer. Now, any thermometer has two major fixed points. Any thermometer has two major fixed points. It has upper fixed point and lower fixed point. Upper fixed point and lower fixed point. So you say upper fixed point, we mean the temperature of steam from pure boiling water. Temperature of steam from pure boiling water at standard atmospheric pressure, that is 760 millimeter mercury. Now, when we're not talking about lower fixed point, we mean what? The temperature of ice, melting ice block at standard atmospheric pressure. So take note of that two major fixed point, upper fixed point and lower fixed point. I said each thermometer has its own upper fixed point and lower. What are the scale that we normally use? in thermometer, we have three major scales. We have Celsius scale, we have Kelvin scale, we have Fahrenheit scale. For the Celsius scale, each scale, don't forget, each scale has its own upper fixed point and lower fixed point. For the Celsius, lower fixed point of Celsius is 0 degrees centigrade, while the upper fixed point is what? 100 degrees centigrade. That is for Celsius. But for the Kelvin, Kelvin is lower fixed point is 273 Kelvin, while the upper one is 373 Kelvin. So in that case, it means when you use Celsius, Celsius scale, if the Celsius is telling you it's 0 degrees centigrade, if you go and take a thermometer that is in what? Kelvin, that one will say no, it's not 0, but what? 273. But when this one is giving you 100, so this one will say no, it's not 100, it's 373, which means increase, 1 degree increase in this one is also 1 degree increase in this one. So this one, if this one is 1, this one will be 274. So until this one will reach 100, while this one will reach what? 373. Now, the third one is Fahrenheit. That one, for the Fahrenheit, its own lower fixed point is 32, while its degree Fahrenheit. While its upper fixed point is 212 degree Fahrenheit. Now, that will now lead us to what they call fundamental interval. That is, when we say fundamental interval, we made what? The difference between lower fixed point and upper fixed point of the thermometer. For this one now, is lower fixed point is 0, upper fixed point is 100. So its fundamental interval is 100 minus 0. So which will give us 100 degrees centigrade. Then, fundamental interval for the Kelvin one is 373 minus 273. So this one also will give us 100. Then for this one is 212 minus 32, which will give us 180 degree Fahrenheit. So these are their fundamental interval: 180, 100, 100. Now, the next one is how to convert the formula. The formula, how to derive the formula for when you want to convert from one scale to another. It's very simple. It's very simple. Let's start from how to convert from Celsius to Kelvin. Now we have this. We have this. The first thing you need to do. So for this one, let's say this one is Celsius, is 0, then 100. This is Kelvin, 273, then 373. So this one, let's represent with C as Celsius. Let's represent this one with K as Kelvin. So if I want to convert, I will just say this minus this over this minus this. Whenever you are asked to convert from one scale to another, apply this method. This minus this over this minus this is equal to this minus this over this minus this, which is simply as 100 minus Z, C minus 0 over 100 minus 0 is equal to K minus 273, K minus 273 over 373 minus 273. So at the end of the day, you are going to have C over 100 is equal to K minus 273 over 100. You can easily cancel this one. So you can cancel like that. So in that case, you have C, that is Celsius K, is equal to K Kelvin minus 273. So Celsius K is equal to, and if you are looking for, if it's Kelvin you are looking for, just make this K the subject formula. So which will give us K is equal to C plus or 273 or C plus 273. So that is that about that. Now, what of if you want to convert from Celsius to Fahrenheit? You follow the same procedure. What you just need to do is to write it. You have this is Celsius, then this is Fahrenheit. For the Celsius, we have 0, 100. For the Fahrenheit, we have 32. Then we have what? 212. So we just say, I'm looking for, let's say this one is C that we are looking for, this one is F. So it will now be this minus this over this minus this is equal to this minus this over this minus this. So what will now happen? This minus this will give us C over this minus this will give us 100. Is equal to this minus this, that is F minus 32 over this minus this will give us 180. Then you cut this 2 here 5, 2 here 9. So you cross multiply, we have 9C is equal to 5 open bracket F minus 32. If it is C you are looking for, just make it the subject of formula. Therefore, C is equal to 5 over 9 into F minus 32. And if it is F, that is Fahrenheit you are looking for, we make it the subject of formula. Very simple. Let's do this real example. For instance, if you are to convert, let's do this conversion. Like I want to convert 30 degrees centigrade, or let's say 50. 30 degrees centigrade to Kelvin. And let's say that's number one. But let's try this one first. We move to the next one. Then in that case, I'll just do like this. Do like this. 0 to Kelvin 273. Then upper this point 100. Then this one is 373. Then 30 is given. I'll write 30 here. Then this one is unknown. I'll write K. Then I follow the same procedure. This minus this, that is 30 over this minus this, that is 100. Is equal to this minus this, that is K minus 273 divided by this minus this, that is 100 as well. So this cancel this. So in that case, we have 30 is equal to K minus 273. So I'll just bring this one here. Since I'm looking for K, K is equal to 30 plus 273. So what will that give me? It will give me 303 Kelvin. So when you are converting from one temperature to another, just make sure you apply this method. So that will be the end of our class for today.